Welcome back. Today we're going to talk about formulas that are geometric in nature. So the first thing I want you to understand is that you should really have these formulas memorized, okay? I'm going to go over some formulas for rectangles, squares, circles, triangles, trapezoids, and hexagons. And for the most part, I will say for all of these things, you will need to have these formulas memorized. It will help you in geometry, which is your next class. Given that you've passed out of Algebra 1. So it's absolutely imperative for you to understand how to do these formulas just off the top of your head. Of course, a rectangle is an object where there's the opposite angles. It's a polygon where the opposite angles are 90 degrees. In a rectangle, the opposite sides are parallel and of the same length. Oftentimes when in geometry, when something's the same length, you mark it with a certain number of dashes. So the fact that these have one dash means that they are equal in length. I could put two dashes here, two because I don't want to just put one, because that would mean that this one and this one are the same length, but they're not. But these two are the same length. So opposite sides are parallel and of the same length, and the opposite angles are 90 degrees. So the area of a rectangle, notice I've just used a subscript here, the area of a rectangle is equal to length times width, all right? So it's often used, there's a script L times a W here, all right? You should absolutely know this coming out of middle school. Perimeter, of course, perimeter is just the, area, by the way, is a two-dimensional measurement, right? It's the space within an object, okay? Whereas perimeter is the length around the object. So perimeter is this length around. So literally, if I just drew a string all the way, or ran a string all the way around the outside of this polygon, and then I put the lengths of the string all together, right? How long would that string be? That's the question that perimeter answers. This is a one-dimensional measurement because it's just a length, ultimately. So of course, perimeter is two of these lengths plus two of the widths. Okay, for a square, of course, what a square is a square is a particular type of rectangle where all four sides are equal. So I can put just one dash here. So instead of using the length and width idea, because in a rectangle, length is not necessarily, so in a rectangle that's not a square, length is not equal to width, but in a square, length and width are the same. So we just call it S for side. So side is just the length of one side here. Of course, in a square, opposite angles are 90 degrees, which really forces everything to be 90 degrees, just as in a rectangle. So the perimeter of a square, you just take the side length and multiply it by 4, okay? And the area is just S squared, or side squared, okay? In a circle, the area of a circle is pi r squared, where r is the radius, okay? And their circumference, now I want you to remember, circumference is the same as perimeter. We just call it something different for a circle. So their circumference is just the length around the circle, okay? Now the length around the circle is going to be, there's two formulas for it. It's 2 pi r, 2 times pi times the radius, or, and remember, this is again a one-dimensional measurement, it's just a length. Whereas area is a two-dimensional measurement because it's the space within an object. Okay, so it's either 2 pi r or diameter times pi. Note that, of course, 2r is the same as diameter. Okay, so it's either 2 pi r or diameter times pi, whichever you have. If you're given r, multiply it by 2 to get diameter. If you're given diameter, then you're one step closer to finding the circumference. Okay, now triangles come in all different forms, right? This is essentially an equilateral triangle here. This is a right triangle, and this right here is an obtuse triangle because one of the angles is greater than one of the angles is greater than 90 degrees. So we call it this one an obtuse triangle. There's also a scalene triangle where none of the sides are equal to each other. So it's difficult for me to draw straight lines with this program that I use. But a scalene triangle is where none of the sides are equal to each other. So I can mark them with 3 dashes. Okay, in a triangle, what you need to do is you need to find the base and the height. Those are the two measurements that are used for the area of a triangle. Now the base is often referred to the side that is looks like it's being put on the ground. So if the horizontal the side that's horizontal here, directly horizontal, is called the base. So it looks like it's just sitting right on the ground. So here in this equilateral triangle, this side right here is the base, and the height is a line drawn from the top angle to the base that meets the base at a 90-degree angle. Okay, so in an equilateral triangle, the height goes directly through it. It actually cuts the triangles into two 90-degree triangles, or two equal 90-degree triangles. So here all the sides are equal, and so here these two sides would be the same, right? And this side, although not equal to the first or the second side, is equal to itself. So these would be two right triangles that are congruent. Okay, that's a lot of geometry for you, but just so you know, that's how we would look at an equilateral triangle if they're all equal, if the sides are all equal to each other. The height, or sometimes the height is also called the altitude of the triangle. Now, in a right triangle, the base is one side and the height is the other side. Okay, so if the right triangle is oriented this way, the base would be called this horizontal line. And since the nice thing about a right triangle is that it meets another side at 90 degrees, this other length right here would be called the height, or the altitude of the triangle. Okay. Now, in an obtuse triangle, what's weird is that when you go from the top angle here down to the base, the line segment is outside of the triangle. And that's okay, as long what you do is you take the base and you extend the side of the base so that it creates a straight line here, and then you take this top angle and you draw a line that meets the extension of the base at 90 degrees, and this is referred to as the height of the triangle. Okay, now this is the area of the triangle, so it's 1/2 the base length times the height of the triangle. Okay, so essentially what you do is you take base times height and create a rectangle, but a triangle is only half of that rectangle, so you take half of that formula. Okay, in a trapezoid, the thing that you have to understand about a trapezoid is that there are one pair of parallel sides. That's what marks a trapezoid. So in a trapezoid, you have usually the sides that are parallel one is placed so that they're both placed so that they're horizontal. And so we call this first one base 1 and the second one base 2. Okay, it doesn't matter if base 1 was on bottom and base 2 on top, as long as you've marked one as base 1 and one as base 2. Now we take a height, which is we take a line segment drawn from a top angle, doesn't matter which one it's going to be, this one or this one, and we draw a line that meets the base here at a perpendicular, or at a 90-degree angle. And we refer to this distance as the height of the trapezoid, right? It's how tall the trapezoid is. So the area of a trapezoid is, you take base 1 plus base 2, add them first, then multiply it by height, and then divide by 2. Another way of looking at it is 1/2 b1 plus b2 times h. So another way you could do it is take b1 plus b2, add them, multiply them by h, and then take half of that quantity, which is exactly what this is saying too. Okay, finally, in a regular hexagon, you need to know the perimeter of a regular hexagon. And by the way, I've been not going over perimeter, but remember, you can get perimeter if you're given base 1 and base 2 and these other sides, then just add all the sides together to get the perimeter, right? In any two-dimensional polygon, you can just add all the sides together to get the perimeter, all right? You don't need a fancy formula to tell you that. It's just some of the formulas are a shortcut. Like in a regular hexagon, regular means that all the sides are of equal length, so I can just put 1 dash on all the sides, meaning they're all equal to each other. We call one side length s, so the perimeter, of course, would just be s plus s plus s plus s plus s, which would be 6 times s, right? Repeatedly adding s to itself 6 times would result in 6 times the quantity of s. So those are the geometric formulas you need to memorize. Now let's go over some word problems involving geometric formulas. So this is a lot like the consecutive integers, where we're going to make a little chart. So the length of a rectangle is twice its width. The area of a rectangle is 72 square inches. Find the dimension. So let's just write down some formulas we need. We know that area of a rectangle is length times width. And what I'm looking for is length and width. I make a chart because there's more than 2 things I'm looking for, so it helps me organize my ideas and remember that I'm looking for 2 things, not just one thing. Okay, so let's represent these things with the algebraic expressions. The length of a rectangle is twice its width. So oftentimes the thing that's supposed to be represented with x is at the back of the sentence. The length of a rectangle is twice its width. So you represent the width with x, and so length would be 2x. Okay, so we have 2x times x is equal to 72 because we said the area was 72. So let's go ahead and solve this. As 2x squared is equal to 72. Let's divide each by 2 here. We'd have x squared is equal to 36. Now we know that there's two solutions to this. X is equal to 6 and negative 6. But remember, this is a word problem that's geometric in nature, so we cast out the negative 6 solution because we're looking for lengths. And so negative 6 is not a length, so we're going to cast that solution out. And let's go back. X is 6, and so twice x would be 12. All right, so 6 times 12 is 72, so that's the area. Okay, let's try another one. The ratio of the length of a rectangle to its height is 5 to 2. If the area is 490 square meters, find the dimension. Okay, so again, area is length times width. I'm looking for length and width here. Okay, if the ratio is 5 to 2, so the ratio of the, and when they say a ratio, the thing that they mention first is the first going to be associated with the first number in the ratio. So the length of a rectangle is the 5, and the width and its height is going to be 2. Okay, so if the length is 5x, then the width is going to be 2x. Okay, so here we have 5x times 2x is equal to 490. So remember, you can just, when you're multiplying monomials together, you can just do the coefficients, multiply the coefficients together, and then multiply the terms with the x in it. X times x is x squared. So you have 10x squared is equal to 490. Divide each side by 10. We have x squared is equal to 49. So x must be, so when I take the square root of both sides, x must be equal to 7 and negative 7. But remember, we're going to cast out a solution that doesn't make sense here. So x is equal to just 7. Now the solution here is going to be 7 times 2 is 14, and 7 times 5 is, that's 14 here, is 35. Okay? And so if you check this, 35 times 14, let's see, you get 490. Okay, so always go through and check it. Okay, and in this last problem, this is particular because we're actually going to end up using 3 expressions. So the length of the second side of a triangle is double the length of the first side. The length of the first side exceeds the length of the third by 3. So essentially what we're looking for is the first, second, and third side of a triangle here, and what we're given is the perimeter. So remember, all I have to do to find the perimeter of a triangle is just add the first side to the second side to the third side. Okay, so let's represent them with expressions first. The second side of a triangle is double the length of the first side. So the first side becomes your x. Okay, and so the length of the second side is 2x. The length of the first side of the triangle exceeds the length of the third side by 2. So what does that mean? To get the length of the third side, we'd have to take the length of the first side and subtract 3. Okay, so let's just make sure this makes sense here. This would indicate that the third side is less than the first side, which is what you want, because we'd have to take x and subtract 3, which would reduce the value of the expression. All right, so now that I've represented all 3 of them with expressions, let's go ahead and add them together. And it's going to be equal to 13 kilometers, so we're going to have to make sure to actually put that unit in our final answer here when we get it. Okay, let's add together like terms. So remember that these are ones here. So we'd have 1x plus 2x plus 1x is 4x, minus 3 is 13. Okay, let's add 3 to both sides here. We'd have 4x is equal to 16. Divide by 4. We'd have x is equal to 4. Okay, so the first x here is 4 kilometers. This one is 8 kilometers. It's actually a really huge triangle, right? It's like a land triangle because if they're kilometers, it takes up a really large space. And the next one would be equal to x, x minus 3 is 1 kilometer. So 4, 8, and 1 kilometers are the answer here. So if you add them all together, 4 plus 8 is 12, plus 1 is 13. It does check out, all right? And that is the end of the lesson for today.